Matai manufactures air compressors from 1.5 to 250 kilowatts. These are oil-injected rotary vane compressors. This technology provides the end user with unquestionable benefits. The air is drawn in by the cooling fan and the compressor. When entering, it cools the main motor, then a part of it enters the compressor and another part the heat exchanger. Inside the compressor, the air passes through the intake filter. Any solid particles are blocked. The air then enters the inlet valve block. The modulating proportional intake valve's movement is driven by a hydraulically controlled piston. The pressure acting on the piston causes the proportional opening and closing valve motion. The pressure depends on the line pressure selected by the user. The valve guarantees a steady operating pressure even in variable load conditions. Finally, the air enters the compressor. The compressor consists of a rotor with longitudinal slots in which the blades slide. The rotor is assembled eccentrically in the stator. During rotation, the volume between blades, called vanes, changes from a maximum value to an almost zero value when the stator is tangential to the rotor and vice versa. When the volume increases, the air intake stage takes place through the appropriate ports, and when it decreases, the compression stage takes place until the vanes uncover the air delivery ports. The compressor sealing is guaranteed by the clearance between the various components and by the oil injection. The air-oil separation occurs in subsequent stages and ensures exceptionally low oil consumption. The hot compressed air mixed with oil passes through the exhaust ports where the first mechanical oil separation stage occurs. A second separation takes place at the final separator inlet before the filters through a labyrinth path due to changes in speed and direction. During this phase, the oil particles tend to drop down because of the force of gravity. Finally, the air passes through the coalescence filters, which remove the oil vapor residues that are still in the air. With this specific separation system, typical of the vane compressor, the quantity of oil carried by the compressed air is less than 3 ppm. After the oil separation, the damp compressed air reaches the heat exchanger. The honeycomb aluminium structure guarantees an optimum cooling of the compressed air. During the cooling stage, the water condensates. This will later be separated in order to prevent the formation of too much condensate in the air distribution lines. Now the compressed air is ready to be used for production purposes.